Hi, everybody. Settled in? So we'll start a session now. Thanks to all of you for taking the time today to attend this session. My name is Harikrishna Menon. I'm a program manager in the XAML Experience team in Visual Studio. Today, we'll take a quick overview of Universal Windows Application Development in Visual Studio 2015 RC. There's going to be a lot of information today, so feel free to come and ask questions during the session itself. We'll have like 10 minutes at the end of the session for a dedicated Q&A as well. So don't worry about it. Just raise your hand, come up to the mic, and ask the question. So hopefully, you have all, did you guys see the Build keynote? So in the Build keynote, they talked a whole bunch about the new Universal Application Platform. So if you have not downloaded 2015 yet, please do it after this session because you really need Visual Studio 2015 RC for you to try out anything that I'm talking about today. You can install the latest Windows 10 from insider.windows.com. The flight that you have to install is 175. You can get the latest VS and the SDK and the tools from visualstudio.com. And finally, once you have these, you're good to go. Please make sure when you try to install Visual Studio, you go to the custom setup and select Universal Application Development Tools. Otherwise, it's not selected by default, so you have to explicitly select it. Otherwise, you won't get the tools. You'll have to go and modify it later on. You can choose not to install the emulators. I think the emulator is around 3 or almost 4 GB. If you don't want it, it's totally fine. We still support simulator, local machine, and remote device deployments. So it's not absolutely necessary you need emulators. So the agenda. We'll take a quick overview of the Universal Windows platform itself. Then we'll basically get on to tooling, the nitty-gritties about tooling. And finally, we'll have some time for Q&A. So what is Universal Windows Platform? For the first time ever, Microsoft has a core set of APIs that work everywhere. Every device family that runs on Windows 10 will have a common core set of APIs. That means, again, for the first time, you can have a single application package. You don't need n number of different installers or different packages for each device family. You can build a single application package. That means we have binary compatibility. You build once, you deploy anywhere. But a standard follow-up question would be, hey, IoT has weird sensors. You obviously are not going to use them in the desktop. Or there are hardware buttons in Windows Phone not available in Windows Desktop. So how do you code against that? So there's a new concept called adaptive code. Adaptive code enables you to check for the API's presence before invoking it. So that way, you're completely fine. You can have a single application package, but still build customized experiences for different device families. Your UI, the kind of APIs that you would use on a Microsoft Band, is very different from what you would write on a desktop. But all that code can be put under these API checks, so your code will never fail. It'll basically light up when that API is available. As you know, the current set of announced families that we have is IoT, mobile, desktop, Xbox, HoloLens or holographic, and Surface Web. All of these devices run on the same set of APIs, the same set of core APIs. And over the course of the session, I will show you certain techniques, how to write adaptive code, some techniques of writing adaptive layout as well. Supported operating systems for Universal Windows development. Traditionally, we have only supported for Windows Store or Windows Phone developing on the latest and greatest. And we guarantee the best possible development experience when you're developing on the latest version of Windows 10 and the latest version of Visual Studio. If you are on both the latest and the greatest, you get deployment to everything. That is, you can deploy to a simulator, a local machine, device, emulators, and remote machines. If you're interested in the fidelity of the designer, if you use a XAML designer or other coding constructs a lot, you can be guaranteed to have a full fidelity designer and a complete IntelliSense experience. But for Windows 10, we have added support for Windows 8.1 as well, and Windows Server 2012 R2. We understand ISVs and enterprises with a lot of developers in the company. It's difficult for them to move all forward or move huge teams forward to a latest operating system. So we understand that, and that's why we have added support for Windows 8.1. But obviously, it's going to be slightly degraded. The reason for that is we cannot deploy an application that is a Windows 10 application on a Windows 8.1 machine because the APIs are just not there. So when you debug, deploy, or profile, you will only have support for mobile emulators, remote machines, and device. The XAML Designer especially has a hard dependency on the runtime because we actually run user code in the designer process. So in Windows 8.1, we don't have access to the same APIs like the local machine. So you will not have a designer, but you will have complete XAML intelligence. So slightly degraded experience, but still you can do the basic coding, debugging, profiling scenarios in Windows 8.1 as well. At RTM, we're going to add support for Windows 7. Again, very similar experience to Windows 8. The big difference being Windows 7 does not come with Hyper-V. So there is no emulator support. You still can deploy to a device connected over IP or over USB, as well as a remote machine. XAML intelligence supports remains the same. So this makes it pretty easy for a lot of folks now to code against UAP without having multiple VMs or multiple machines. Hopefully, it should just work on a development environment. You could just be able to go and build universal applications on your dev environments now. So project templates. I'm going to switch to Visual Studio for this one. Is everything big enough, right? Looks good. OK. So as usual in VS, you go to New, Project. And there is a new Windows Universal node in the New Project dialog. You can see that we have, by default, shipped blank application. It's pretty much a blank template. We have the class library, which basically is a managed library. Then you have the Windows runtime component. That is you use if you want to share your code between different languages. Like you have written a library in C++, that is a Venati component. You can consume that in JavaScript, and you can consume that in C# as well. So that template is also available. Finally, we have a unit test template. Previously, we had shipped things like grid, hub, split, and navigation. Those templates are no longer available for Windows 10. Instead, what the Windows team has done is they have published a large number of really great samples on GitHub. You can go download all these samples now and list in that repo, clone that repository. It's pretty great. It's always updated with the latest and greatest. It has every sample that you can imagine that'll help you write adaptive, great Windows 10 applications. So highly recommend you, once you install the tools, to go clone the repository, or at least the folders you would be interested in, and take a look at these samples. Switching back to VS. So this is a URL. You can just find it. It's pretty, if you just search for it, you should be able to find the GitHub repository for this. The next thing I'm going to talk about is project properties. It's a bit different from what you would have expected in Windows Phone 8.1 and Windows Store 8.1. If you open a project property for a Windows Universal application for C# or VB, you will see a couple of new properties. The first property is called target version. Target version of the UI, it is backed by the target platform version property in your CSproj or your VBproj. So what does this property do? This defines the SDK that you're building against. This defines the available API surface. So when you say your target version is X, that is always the whole available API surface you can compile against. If you try using an API that is not available in the target version, the compilation will fail. What happens to this property? The Apex manifest file is a manifest file that every Apex or every Windows application carries with it. It has certain properties that is used by both the operating system and the Windows Store to do certain filterings and those kind of operations. This particular value, target platform version, is stamped as max version tested. So let me explain that a bit. What max version tested means, let's say you are using API A in 169 build of Windows, right? It works great, you have tested it, everything is fine. But this API in 172 build changes a bit. The behavior is a bit different. And your customer is installing your 169 application on a 172 version of Windows. So what Windows does it looks at this property and says, hey, this guy's only really tested against the 169 build, so it automatically quirks it. What we mean by quirking is that the behavior for that new API is basically the behavior for 69 and not 72. Internally, Windows has a different code path that makes sure the behavior that you saw while testing on 169 is exactly the behavior the customer will see on 172. So this is a very important property, and it has to be filled. There's no getting around to that. The second property is min version. This is backed by the target platform min version property in the CSproj. It defines the minimum version that your application supports. That means, let's say your application is built on the latest and greatest, that is 175, right? What if a customer is trying to install your application on 172? The store will not allow that application to be installed because obviously it's going to fail. You might be using an API that is not available. So this version tells store that, hey, prevent the installation of this particular application on the customer machine. And that is what that value is used for. One thing to note, though, is the best possible thing you can always do while building your application is keep the minimum version as low as possible and the max version as high as possible. That way, you pretty much guarantee you can be installed on every single Windows 10 device out there. You maximize your monitoring potential. When you upgrade to newer target versions, you are able to use new APIs, get better behavior, so that way your application gets better. And when you keep the min version as low as possible, even customers who are not really updated for some time will still be able to use your application. So it's very important that you keep that in mind, the values for the max version tested and the min version when you define your manifest. So let's take a quick look at VS and to see how these properties are set. So I have a simple cookbook app that I'm going to use for most of my demos. I'm going to click on Properties, so you can see those same values here. Right now, there is only a single value. That means I've only installed a single SDK on my machine. Tomorrow, you might get a new SDK, so you can install that SDK. You can install tens of SDKs, and all those SDKs will show up as individual entries in that combo box, and you can choose which ones based on what you have tested and what you have developed your application against. So both things will show all the SDK values currently installed on a machine. Right now, I only have the 169, which is the released version, the RC version of the SDK. I'm going to switch back to, sorry. Here. So right now, we talked about how to build against the base set of APIs. So how do you actually access APIs that is only available on mobile, or only available on desktop, or only available on IoT, Xbox, HoloLens? So what Windows has done, they have separate extension SDKs. If you're not familiar with extension SDKs, it's basically how third-party vendors, libraries, even Microsoft ships SDKs on the Windows operating system. It's basically a rule set that says, hey, you have to have your folder structured this way, there is an SDK manifest, and everything. So what separate Windows device teams have done, they have built their own extension SDKs. And if you want to, let's say, access an API only available on the mobile SDK, you would add a reference to the mobile extension SDK. If you're building an application for IoT, you would add a reference to the IoT reference SDK only if you're using an API that is specific to IoT, otherwise it doesn't matter. So let's do a quick demo of how to write adaptive code using Visual Studio 2015 and for a mobile device. So close this. I'm going to first deploy this application just for you to see how it looks like. It's a simple cookbook app. All it does is show a bunch of food categories. You click on it, it shows all the available recipes. You click on a recipe, it just takes instruction for that recipe. So you have appetizers, it shows recipes. It's a very simple multi-page application, right? I'm going to now deploy this app on an emulator. So currently it was deployed on the device family desktop. I'm just going to go select an emulator and deploy it. Apologies, I should have warmed up my emulator. This is going to take around 30 seconds, but I accidentally closed it. So you can see that it's exactly the same app. I have not done a thing different. It is directly deploying on a mobile device or a mobile emulator. For a sec. Great. So we built this app with adaptive UI in mind, so you can see the layout and stuff changes when it's a smaller device. So it looks pretty decent. But what happens if I'm going to a page and I want to go back? Traditionally, you can click this back button. But on mobile devices, Windows mobile devices, you have a hardware back button. And that is the only device a hardware back button is available. You don't have a hardware back button in Windows desktop, right? So if I actually select this guy, it just basically exits because I haven't really coded anything specific for a mobile device at all. So it doesn't really, it's not a good system citizen. It's not behaving according to the design guidelines for Windows mobile devices. So let's try fixing that. I'm going to stop debugging. I'm going to open my recipes.xaml. I know the API for accessing phone. So by the way, I have already, if you didn't add a reference, you have to add a reference to the mobile SDK, like we saw before. So if you go to Windows Universal, extensions, you can see that I've already added a reference to the mobile extension SDK for Universal Apps. So I already have all the APIs referenced, so I'm good. Otherwise, you have to add a reference if you don't have add a reference before. So I'm going to do Windows phone.ui input. I'm basically subscribing to the backpress event for the hardware button. I'm going to create event handler. Now, if I run this code on the emulator, let's see if it works. So in this code, all I have to write in that event handler is basically frame.goback, and it'll just go back to the previous page. It's pretty simple. You can see I'm in appetizers, and I hit the hardware button, and now this particular event handler is working. But can anybody tell me what's going to happen if I change this to local machine and F5? Any ideas? Huh? Oh, yeah. So totally right, but let's see how it fails. It's like a face bomb. But so I'm just changed my deployment target to a local machine, hitting F5. Oh yeah, so you can see a type load exception. That's what exactly you would expect because hardware buttons are not available on desktop. That API does not exist on the desktop version. So when the application ran, it couldn't find the API. That's why it crashed. So how would you write code that can still maintain being a binary compat across different versions, different device families, but still be adaptive? So we can do that by using a new set of APIs in Windows called API information. So I'm going to add an if statement. Windows Foundation metadata, API information. So let's take a look at the API information. What the API information does, it's like, kind of like, think about like reflection way. It basically has a bunch of methods that lets you check, hey, is that a property? Is this property present? Is this event present? Is this type available? Or is this method available? So it allows you to make sure that API is available before actually calling into it. That way, you don't have a problem, right? We're never calling APIs on devices that don't have it. So I'm going to just check for this example, is type present. Going to copy hardware buttons type. So some folks have a question, can I write my own API contracts, right? Unfortunately, no. Contracts are exclusively for the operating system. You can't really write your own version of a contract and use the API information to a type check. That doesn't work. It is exclusively only for Windows APIs. So now you can see that I've added a type check for is Windows hardware button enabled before even calling into it. I'm going to run this again, but put a breakpoint over here. Select appetizers. You can see the breakpoint got hit. If I do an F10, it basically failed the check. So now the same code can work well in both Windows Mobile as well as the desktop on local machine. So this is how you would write adaptive code going forward. So take a look at the whole Windows Foundation metadata namespace as well as the API information class. That is a primary way that you'll be doing this going forward. So we talked about adaptive code. So now you know how to still have a single application package, but make sure you can use the wealth of other APIs available in specific device families. The second question most folks have is that, hey, you showed us how to use APIs, but what about UI? My UI for my application on a Microsoft band would be radically different for the UI for the same application on Windows Desktop or Windows Mobile. So you need to have a way to declare your UI or work with the UI so that it flows beautifully between different device families, but still you can ship a single application package. So the Windows XAML team has done a lot of amazing work this release to make this happen. The first layout approach is what we call controls and panels that adapt automatically. You can do that yourself, but Windows, a lot of the Windows controls in Windows 10 automatically realize based on the screen size or device family, it automatically changes its look and feel, or even its behavior. So it fits well with the design language for that particular device family. A common example, I'll show a quick demo, is for Pivot. Pivot does this really well. The second way is we have a new concept called adaptive triggers. These triggers watch out for the min width or min height property of a particular screen. And based on that, you can write a visual state that will modify your UI to work well for that device. And finally, you can even write tailored views. You can have the same code behind file, but multiple XAML files, and each XAML file for a separate device family. So you can write recipe.mobile, recipe.desktop, recipe.whatever, and all these files can share the exact same code behind, but Windows will load the right XAML based on the device family executing on. So let's take a quick demo. I'm going to do a demo of controls and panel, one control and the tailored view. Harini has an amazing session on Friday, which you should definitely attend, because I wouldn't do justice to this whole topic if I even spend the whole hour. It's a big topic, so I'm going to do a quick demo, and Harini is going to do an in-depth dive on Friday on the specific topic of adaptive UI layout. So let's switch to Visual Studio. Sorry? Okay, great question. So the question was, how about mouse events? Microsoft has standardized on what we call the MS pointer spec. So everything for us is a pointer event. Doesn't matter if it's a touch, stylus, mouse, keyboard now, but everything else is basically for us is a pointer event. And the pointer event, you can detect what device type raised it. So pointers by default are already adaptive. It was already so in Windows 8.1. Even Chrome is actually, the web standards, I think, are adopting the pointer standards as we speak. So that's how, it's a common code. You don't have to worry about it. It's a great question. So let me switch back to VS. First, let's take a look at what adaptive controls mean. I have a pretty simple app. All it does is it has a pivot with 6 items on it. And I've set the selected index for the pivot to 5. So let me F5. So you guys know about Windows Phone. Pivot in the selected item is always the leftmost one, right? You basically select the next one that moves in, everything else rounds up. So the design language says the selected item is always the one on the left. That is great. But if you look at the pivot control now, and if I slowly extend it, see what happens? When it's a desktop size, like there is more screen real estate, it behaved like a tab control. So the selected item number 5 is actually on the end, just like we'd expect with any tab control in any operating system. But watch what happens when I reduce the screen size. See? It behaved like a mobile, what would behave on a mobile device. It became the leftmost one. So a lot of these controls have these inbuilt behaviors to respond to these kind of changes and adjust automatically for the design language for that particular device family. So you don't have to do anything. This is out of the box. Let's take a demo of tailored views. I have a slightly modified version of my cookbook project. But there's something wrong with this version. I'm going to deploy. As we saw, this works exactly the same way on mobile, so it's beautiful. The adaptive UI, everything works. But on desktop, unfortunately, it doesn't. And let's see how we can use tailored views to fix that. It's already out. Oops. I think there's a problem with the same name deploying twice. Yeah. Let me start it again. Okay, that works. So if I go to appetizers and I go to recipe, it doesn't look all that hot. Basically what's happening, it's using the same mobile layout, right? I could have done a much better design because I have so much space. I could have moved this whole thing over the left side or something, but right now it looks like crap. So let's use tailored views to fix it. So going back to VS. So there is something called Modern Resource Technology, or MRT, that came with XAML in Windows 8.1. It's a pretty awesome way of basically Windows to figure out certain paths and accordingly load resources. So what I'm going to do is take advantage of that and create a new folder for desktop view. So I'm going to call it device family -desktop. And this is compulsory. Like, this is the naming scheme you have to use, otherwise Windows will not find the file that you're looking for. So I created device family desktop. I already have prepped a working XAML file that looks great for desktop previously. So I'm just going to add that file. Go add, existing item. So I have that file over here. I'm going to add it. Rename it a bit. So one thing you can notice is it's just a XAML file. So where is a XAML.cs? That's because this XAML file, if you open it, you can see the xcolon class is recipe instructions. It's using the same recipe instruction XAML.cs as recipe instructions here is using it. So this code behind file is shared by every XAML file that you map to that particular file. So that's pretty great. So you can have a single code behind, but different views for different device families. All I have to do now is do a rebuild. And deploy. So the UI is now fixed. So what Windows did, it detected when it tried to load recipe instructions, it found a recipe instructions exclusively for the desktop family, and it loaded that instead of the other version. So it's pretty easy for you to build tailored views this way. You can depend upon Windows controls, and visual states and adaptive triggers is another concept that you can see it in the Friday session. Sure, go ahead. No. Xamarin Forms is still XML compatible, but there are big differences in the control set and everything. So it's not directly, you can't copy paste. I'm going to switch back to slides. So we saw how to use a device family SDK when we did the hardware buttons demo using the mobile SDK. What do you do for third-party extension SDKs like Telerik or Infrajustice? Those guys create a lot of great controls for you, and how do you use it? So what we have done is you can reference the existing 8.1 extension SDKs in Windows Universal projects. But you cannot reference Windows Phone 8.1 extension SDKs. The reason is we did some analysis between both the Windows 8.1 version and the Windows Phone 8.1 version of most popular SDKs, and what we found out that they're pretty much similar, so there's no sense in supporting both. So we only support Windows 8.1 SDKs in Universal projects. If you strongly feel that, hey, this is not right, my contact information is at the end. Feel free to reach out to me, and we can discuss what you think we are missing based on this approach. Another thing that is different is you can write your extension SDK in C++ and still use that in managed applications, or you can write in C++, use it in C++ applications. Previously, when we reference a native C++, we used to always add a reference to the CRT runtime, the Visual C++ runtime. But unfortunately, if you reference an 8.1 native SDK, you need to add a reference to a new CRT. This CRT, or C++ runtime, this CRT is exactly similar to the 2013 CRT. The only difference is it has a new package manifest. The package manifest is quite different between 8.1 and Universal projects, so we had to basically repackage it with a new manifest. So if you're referencing a native SDK, make sure that you reference this CRT instead of the previous one. Developers can, at this point in RC, build your own extension SDKs for Universal Windows Platform and write adaptive code inside it. So theoretically, you can have a single extension SDK that has device-specific behaviors, and you can ship that to your customers. All extension SDKs have to be installed to the location on the screen. It won't work otherwise because we won't be able to find those SDKs. Let's do a quick demo of consuming a third-party SDK. In this case, almost first-party. So how many of you know about behaviors? OK, great. So for people who don't know what behaviors are, behaviors is a way to add interactivity to your application without writing a line of code. For example, on a click of a button, I want to go to a different page. Theoretically, what you would do, you would write an event handler for that button. In that, you will write a frame.navigate or something. With behaviors, all you have to do is add a couple of lines of markup, and it'll automatically do the navigation for you. So we shipped this in WPF Silverlight. We had a version for Windows 8.1 as well. I'll show you how to use the 8.1 SDK in a new Universal application. For that, I'm going to use Blend. So like any other SDK, I would add it from references. I'm going to go to Add Reference, Extensions. You can see that I've already added reference to the Behaviors SDK, XAML. If you look at the path, I'm not sure if you can see it, it's actually coming from the 8.1 directory. There is a small warning symbol that basically tells our developers that, hey, you're referencing an 8.1 SDK in your Universal Windows project. It is completely supported, but just be aware, because we always want to tell folks if they're not referencing the latest and greatest, right? So it's just a warning. You don't have to worry about it. It's a completely supported scenario. It's already added, so I'm not going to do anything. I'm going to switch back to the assets pane. So what I want to do here is on the click of this back button, I want to go to a different page. So that's what I'm going to try to do. So all I have to do Because I added a reference, it already shows up. You can see all the behaviors from the SDK in my assets pane. I'm going to select the event trigger behavior and drag it to the back button. So the behaviors SDK is kind of intelligent. Actually, the blend code is intelligent. It knows that, hey, the user is dragging an event trigger behavior to a button. The most popular event for a button is click, so it automatically wires it up for you. So you can see the event trigger behavior is tied to the click event. That means the behavior will execute every action under it when the click event is raised. And I want to navigate to a different page, so I'm going to drag the navigate to page action under the event trigger behavior. And what navigate page action does is whenever that action gets invoked, it will go to the page described in the markup. So here I'm going to select my target page as categories. There's a bug, so when I select it, it's actually set, but it goes away. To prove that it's actually set, I'm going to show it in XAML. You can see the target page is set to cookbook categories. So it's that simple. So whenever somebody clicks that button, it will automatically move that person, that page, into the categories page. So, sorry? Does this allow you to write? Oh, totally. Yeah, behaviors is completely extensible. You basically derive from iBehavior for writing a behavior and derive from iAction to write an action. So, yeah, so this is how you would actually use a 8.1 behavior in a Windows Universal project. Switching back to slides. So this is interesting only if you are an extension SDK author, so I'm not going to spend a lot of time on it. I'm going to move on. But the couple of things you have to note that is different is, A, if you're writing a manifest, you have to set the target platform to UAP. That's how we know it's a universal application platform. It stands for Universal Application Platform. That's why you know it's a Windows, it's an extension SDK that customers can use in a universal application project. The second properties that you should be concerned about is SDK type. You don't have to set it. We always consider, if you don't have SDK type set, we always consider as external. The other values for SDK type is platform for device family extension SDKs like mobile or IoT, and the other values for framework, that is for CRT. So you can't use those. So if you're writing an extension SDK, you can put the property or not. We'll always consider as an external SDK. The target platform min version and target platform version is exactly the same as what we described before on project properties. It basically allows us to filter what SDKs you can reference in your application. For example, if your application is 165, we can't really allow you to reference this SDK because 169, right? So we'll basically not show that up in the add reference dialog. So that's all we use this for. If you are installing your SDK as part of a VisX manifest or Visual Studio Extensibility installer, you have to set the target platform identifier as Windows Kits and target platform version as 10. That's how the VisX installer knows where to install the SDKs. Not very interesting, except for those few folks who actually build extension SDKs. So NuGet is super popular. Everybody loves NuGet. Everybody references NuGet. So I'm happy to announce that Windows Universal projects can reference, like extension SDKs, Windows 8.1 NuGet packages. It's already available. So if you're developing a new universal application, you can go right now, add a reference, manage NuGet packages, and we'll see a quick demo of that, and reference anything that you want from Windows 8.1. So let's do a quick demo. So I've already created a project. It's demo NuGet. All I have to do is right-click, go to Add References, Manage NuGet Packages, and it shows you all the available packages from NuGet.org. I'm going to quickly search for MVVM Lite. It's like one of the most popular frameworks out there for MVVM. I'm going to hit Install. And this is just standard NuGet installation. You can use any NuGet package in any Windows 8.1 NuGet package in your universal application going forward. This is going to take a bit of time, so I'm going to switch back to the slides and talk about what we're going to do for the RTM version for NuGet. So all it does is adding references, and I can build it and use it like any other application using NuGet. At RTM, we will allow you to reference Windows Phone 8.1 NuGet packages. This support is just not there right now. Developers will be able to author your own NuGet packages. Currently, it is not supported. You can use 8.1, but if you want to author with adaptive code a universal Windows specific NuGet package, that is currently not possible because NuGet.exe needs to be updated with the knowledge of the universal platform. But we do have private bits. So if you're interested in trying it out, if you are a NuGet package library author, do reach out to me. My contact information is there, and I'll give you access. I'll try my best to get you access to the preview bits before RTM. App Insights. Everybody knows about App Insights, right? Hopefully, yeah? So App Insights is the new telemetry client for Universal Windows projects. Be it a developer, be it an enterprise, it is super important for you to know the usage characteristics of your application. You need to know if your application is performant. You want to know if your application is reliable. You want to know what pages are being used. You want to have real-time understanding of what's happening in your application. Without writing a single line of code, you will get most of this for free. So when you add application insights to a project, or you create a new Universal Windows application, application insight comes from the default. And it automatically instruments your app and sends all the data that you need for basic scenarios, either to the store portal where you're publishing your application, or if you have connected it to your Azure subscription, you will find your application on Azure and all the associated telemetry data there. So App Insights is a recommended telemetry client for Universal Windows projects, and it comes it comes with default for every new Universal project. If you have an existing project, you can just with one click add support for it, and I'll show you how. And developers can also add their custom telemetry. For example, in my cookbook application, I could add telemetry saying, hey, what categories are people clicking on? So I can invest more time in adding more recipes in that category, right? That's how I would monetize my application. I would understand what are the common usage patterns, make those common workflows super easy for our customers, understand what I could do for features not being used to make it better or make it more accessible, as well as monitor performance and reliability issues. So let's do a couple of demos on App Insights. No worries. Good ringtone, though. Yeah. So that's not the one. I have so many cookbooks open. OK, this is the one. First, I'm going to show you the experience when you create a new project. So if I go to File, New, Project, what you can see here is on the right, you can see Link Application Insights resource with existing Azure account. So provided I'm signed in, and so Visual Studio knows my Azure accounts, it's automatically downloaded all my subscriptions, and it automatically enables me to attach a new application directly to my Azure subscription. I'm not going to create a new app here because App Insights, adding it, connecting the resource takes like a minute or so. So we don't want to spend a minute staring at the screen. But essentially, when you click OK, that's it. That's all you have to do in terms of configuration. Your subscription is set up. If you have a subscription, the connection is set up. The moment you launch that app, all the data is going to be sent to the cloud. So instead of doing a new project, I'm going to add it to my existing cookbook application. I haven't added App Insights to the application yet. So I'm going to go to Cookbook, right-click, and add Application Insights Telemetry. So you can see that VS found my credentials. It found all the subscriptions on my credentials. And I'm going to say, hey, for this application, send it to my Cookbook app, because that's what I was using, my existing resource already created. And I'm going to click Add. At this point, what happens is we download a couple of NuGet packages that has all the App Insights code required to send all this telemetry. We add those references, make sure the the app IDs associated, all that fun stuff. So give it a minute, and we're done. So now if I F5 this app or deploy this application on a local machine, play around a bit. Sorry, let me delete all these breakpoints. And if I view my output window, you can see that App Insights is sending telemetry on my behalf. So that's it. All I did was a single button click, actually 2 OKs, and I was done. Provided my account credential setup, and all my App Insights telemetry is now going to the cloud. And you can see this pop-up that says, hey, it's the first time for this project. Some telemetry has been uploaded. Let's go take a look at that telemetry. So I'm going to click on over here. This is going to automatically, hopefully, log me in. Otherwise, I'll have to put my password. Yeah. Don't stare at the screen. I'm putting my password. So, yeah. Yeah, so this logs into Azure and automatically opens my application inside resource. That is my Cookbook app. And as you can see, I haven't added any code. All I did was just add a reference to, basically said, hey, add App Insights to my code, right? The first thing you can notice is a bunch of awesome data. It tells me that, hey, I have had 2 users in my application. So if I click on it, it tells me both users were in the United States. So it even tells me the geographic distribution of where my users were and who's using the application. The second one is sessions. It tells me there was a total of 12 sessions on my application version 1.0.0. If I had a different version, it would tell me for that version how many unique sessions were for your application. It even tells me page views by default. So it basically listens to the Frame Navigate event, and it tells me that, hey, 20 page views on cookbook.recipes, 17 on categories, and 8 on recipe instructions. So this allows me to understand what pages are being used most in my application.
How this deploy this application in mobile, so I have a data restriction. Does it prompt me to send the request to Azure?
So that's a great question. I believe there is I think they will ask you for permission first as you create the app, but I'm not sure if you can completely opt out of it, because certain things like crash information, I think it bypasses most things. But I can follow up for you and let you know. Yeah, go ahead.
If we were to run, say, the Azure Stack on-premise,
Yes.
would this be sent to that instead of out to the cloud?
I believe you can configure it to send it where you want it to, but that's a great question. Not an Azure expert, but definitely I can follow up for you and I'll let you know how that works out. But currently, this is on the public cloud for me. All my stuff's in the cloud, so you can see that, hey, page views, how it looked like. It even tells me crashes. It tells me that, hey, I had 2 argument null exceptions in my application in the last 24 hours. Pretty bad. It's not pretty bad. But it allows me to quickly look at what's the reliability of my application, and even tells you the stack trace, by the way. So if I go over here, you can view the simple stack trace for that particular crash. So it's very easy for me to quickly debug simple things like null refs and stuff. I can look at it here, see if it's a big problem, go and fix my code. A couple of other interesting data points that this shows is it tells you top sessions by country that we already saw. It even tells you the kind of devices your application was running on. Currently, I've only ran it on my laptop, so that weird ID like 20CO5, that's on my laptop. So if you had multiple devices, each device will say, hey, you ran on Lumia 520 or 620 or whatever. So you can track what device you're using to sync. It tells you the version of the operating system that was running your application. It even tells you the resolution you're running against. So that is pretty good. So it helps you understand, hey, should I write a new UI for a specific view if a lot of people are using it, customized for that particular size? So that's a quick overview. And if you really want to dive into detail on every single event that you're getting, you can click on Diagnostic Search, and you can view your individual instances. You can see that this guy was sent like 5 minutes ago, the last time I F-filed. I think like 30 seconds, you'll see your data up there. So it's real time. Sorry?
What kind of governance in place for the data contract? Like, I may not agree with this data.
Oh, your PII, right? You're talking about PII. I think I should double check, but I think you have to give permission for anybody to collect this data. But right now, it's pretty difficult at the end of the day, because if you have an application that always connected to the cloud, so as long as there is a usage restriction that most companies do, but there are applications that already collect this data, you can't really help it. It doesn't really need App Insights. It could be a simple web service that you can send data back as well. But
Data structure. The structure of the data.
oh, sorry, my bad. So the question is the structure of the data. These are all predefined events. These are all predefined by the platform, but I'll show you a demo how to write your own custom event. So that you can define your own data structure, you can define your own properties, you can define as n number of custom events as you want. So the scenario I'm going to show is I want to basically track what category is the most popular category in my application. Like is it soups or appetizers or whatnot? And I'm going to write a simple code to try that out. Switch back to VS. Stop debugging. I'm going to open recipe itself. In the onNavigator function, before I write my code, when you added application insights, it did a small thing. What it did was it added a line of code. It basically added a public static telemetry client to app.xaml.cs, and it has already initialized it. So all I have to do in my code is do app.telemetryclient.track event. Give a name for my event. I'm going to call it categories. I'm going to call it categories, yeah. New dictionary. I'm going to add a property for my event and call it category, and the name of the category, that is e.parameter.string. And that's it. That's all I have to do to add a custom event to my application. It's already all set up for you. So if I F5 this app, deploy this application, and go back to Azure and refresh it, I should be able to see these events up on the cloud. So I'm going to go click on recipes, go back, click on soups, do a couple of more clicks. Salads, stop debugging. Okay, let's refresh this. Somebody's hogging the Wi-Fi. Huh? Only 23,000 people, I know. You might have to trust my word here. Yeah, 410. So you could see a new event that got added. And 410, this is a new categories event that added. So it's real time. I just added a new custom event, and it just showed up. So you can add your own custom events pretty easily by using telemetry client once you have added application insight support to your application. So switching back to the slides. So we talked about App Insights. So this is going to be an interesting topic. How do you upgrade your existing Windows Phone 8.1 or Windows Store 8.1 application to universal Windows projects? The first technique is pretty simple. What we call it is a single universal Windows project. What you would do, you is add a new application for new application. You will use adaptive code to write device family specific APIs. You can support different form factors using adaptive UI. And what you can do is you can take all the code, all the shared code that you had on a Windows Store 8.1 or Windows Phone 8.1 project, move it to shared projects or portable class libraries, and reference all this from the new universal project. So that way you can share a significant amount of code, but yes, you have to write some scaffolding to use all that assets in the new application. So your application looks initially, when it was Universal 8.1, it looked like this. It had two heads, one for Windows Phone, one was Windows Project. You probably had a portable class library. You probably had a shared project. In the new world, you'll basically add a new project called myapp.universal UWP, and you'll basically add reference to the shared project and the My Portable library and reuse all that code. I know it's not that simple for the majority of applications, but it's pretty easy. If you have really structured your code, if you had reusability maximum in mind between Windows 8.1 and Windows Phone 8.1, this should be more simple for you to go forward. The second thing is device-specific universal Windows app. There could be a business reason that your business tells you, hey, I don't want a single application package. I want one for desktop, one for mobile, and one for everything else. There could be some particular reason that you want it that way, right? For your client wants it that way. If that's the case, there is a technique. So if you look at it here, the target device family says Windows.mobile. By default, it always says Windows.universal. If you just change that to mobile, it will only get installed on mobile devices. The store won't even show it up for anywhere else. So that's how you would create for separate device families. You would change the target device family from Windows.universal to a specific device family name. And the min version and the max version tested should correspond to that particular device family. You can imagine a world where different device families in Windows have different release cycles, right? Mobile might be a couple of numbers ahead versus Windows desktop. If that's the case, you have to use those specific versions there for the both min version and max version. And these version numbers will be documented somewhere on MSDN for you to take a look at. But that's a big thing. Okay, go ahead.
Do you have multiple devices there? You might want to release for two different devices and then later on do other devices.
Oh, yeah, totally. So
you have multiple in that string. So you say Windows Mobile, Windows Desktop.
No, I believe this currently only supports per device. That's a good question. I'm pretty sure it only supports one device. There's no comma separator at this point. So the technique that we are showing here is that you create one for mobile, and you would then again use the same technique of sharing code between PCL, portable class libraries, and do the same thing. So instead of having only 4 projects, you now have 5 projects. In your new world, you will have one for UWP, and you will have one called UWP.mobile. The UWP.mobile will only be used for mobile applications, for mobile devices. The other UWP will be used for all other universal platforms, device families. Let's do a quick demo of this. I think it's a little easier if I show it. So I have a very simple Windows 8.1 universal project. That means it has a portable class library, it has a shared project, it has Windows 8.1, it has Windows Phone 8.1. If I want to add a new project here, all I would do is right-click, add new project, and call this demo upgrade. UWP. And that basically is my default one for when I use a single application package for all device families. Yeah, this is a problem with application insights. But you get the idea. All you have to do is add a reference. Now I can just go add a reference to both the shared library I have over here and the portable class library, and I'm able to reuse a significant amount of my assets that way. I'm just going to go references, add reference, go to shared projects, add a reference to the shared project, add a reference to my portable class library, and click OK. And that way, I have a new head project for all universal devices. What if I want to change this to only mobile only? All I have to do is open the application manifest, right-click, open with an XML editor, and instead of target device family universal, I'm just going to delete that and replace that with mobile. And now this is only going to be installed on the device family mobile. So it's pretty easy. You can, based on your business requirements, you should be able to figure out which technique works for you and which doesn't. Both are completely acceptable. So we're coming to the last topic of the day. Do you guys know what .NET Native is? Right? So .NET Native is a pre-compilation story for managed applications into native code. What it does is you can think about taking your MSIL and converting that into native code specific for each architecture on your machine. So this enables a couple of things. Amazing perf. Your startup is significantly faster. In some cases, from 30 to even 60% in our labs faster. Your startup memory is also pretty low. It brings it down by 20%. So this almost gives C# outside of the GC managed applications similar startup and memory footprint compared to native applications. So you can write your code in C#, get all that awesome productivity, but get the same performance as a native application by using the .NET Native toolchain. You have no control over this. Once you write a managed application and submit to the store is going to compile that into a .NET Native application. You don't have to do a thing. So the end package that's installed on a customer's machine or a consumer machine will be a .NET Native package. Any CPU is no longer supported for managed languages because of Project N. You will have to, when you submit an application to store, you have to build x86, x64, ARM versions of that package. But that'll be MSIL. You don't have native. What the store does is once it takes those packages, it runs the .NET Native toolchain in the cloud, compiles it down, creates a new .NET Native package, and pushes that down to customer machines. Oh, great.
Modify to engine, native generation, is there any performance difference?
Engine is unfortunately, Engine has to run on the target client machine. Does that make sense? You cannot engine on your machine and ship the engine binaries to a customer. It just won't work.
When you say native,
Yes, it is very similar to Engine, but in some ways it's better than Engine. In what .NET Native does is it takes all the framework libraries and statically links that in the application. So your executable actually contains all the CLR types you're using in your project. So your size is a bit bigger, but at the end of the day, you get much faster startup. So the performance is the biggest driver for us to do Project N. And it is similar to Engine, but it has added incentive of static linking and all that stuff. And Engine has to happen on the customer machine. You can't do it in a cloud and ship it down. It just doesn't work. So any CPU can be used for class libraries and Venautic components because you can't really deploy a class library or a Venautic component. It has to be consumed in the application, right? And the application and its .NET toolchain will basically convert this to a .NET Native thing while compiling. By default, debug, while you're debugging, you're running against a core CLR, and you're not doing .NET toolchain. The reason is because of the static linking and conversion to native code, it's pretty slow. So it's like a good 40, 45 seconds slower than a general simple build. So you don't really want to get hit with that performance impact every single time you're debugging application, right? .NET promises a really fast deploy debug workflow, but if you actually do .NET toolchain every single time, your workflow might get impacted severely. So by default, we don't enable .NET toolchain and debug. It is only enabled when you build release. But this is interesting. If you really want to do it, you can do it. That is a property for you, but we would encourage you not to do it. So this is a little different because previously, you would do debugging. If you test and debug, you're sort of kind of sure that you're OK, right? But now, slight behavior changes could exist. We have tried our hardest for that not to happen. When you debug, it should have the same behavior in release. But we would highly encourage you to make sure you test your release bits regularly since the .NET Native toolchain is involved. So how does your .NET Native developer workflow look like now? You would create a C# VB universal project. You would always build and run and debug. That means x86, x64 ARM. You can always do that locally and debug without having a .NET Native toolchain. But when you're testing, you should test on release. And when you build release, it'll automatically invoke the .NET Native toolchain and build that for you. And if you want to deploy, you would basically build release x64, x86, and ARM packages. What the store does, it takes that package and compiles that down to the same .NET Native toolchain you have used on your machine. The application manifest has enough information for that. And then it pushes that particular .NET native version of the Apex down to customer machines. So developer workflow has slightly changed. You should pay a lot more attention to your release binaries and do your testing as much as possible on the release binaries. That is what your customer will expect on his machine. That actually wraps up my content. The Windows 10 samples, you should try it out. I love Developer Assistant. It's this cool thing for, especially when you're using a new API, you have no idea how to use that API. It'll give you tips while you're completing IntelliSense on how to use that API from Bing. It's available for 2015 on the gallery. These are some of the related sessions that you should probably think about attending. That'll give you much more detail about the topic that we discussed. Especially, you should go for the 2310 for adaptive UI. So here's my contact info. I'm pretty responsive on email or Twitter. Feel free to reach out to me if you have any questions, concerns, feedback. And if anybody has any questions, I'm free. Thanks, guys.